Black holes have long baffled astronomers and scientists. It is well known that these enormous objects have extremely strong gravitational pulls from which nothing can escape, not even light. This makes it hard to look inside a black hole or examine what is there. But, recent advances in science have made it possible for us to see into a black hole for the first time. When a large star collapses in on itself, a region of space known as a black hole is created, which has such a powerful gravitational pull that not even light can escape it. Scientists have spent a lot of time attempting to comprehend these items since they are so wonderfully fascinating. The inability to actually detect black holes has been one of the main obstacles to research. Yet, in 2019 the first ever photo of a black hole was taken by a team of scientists, making scientific history. The Event Horizon Telescope, EHT, a global network of telescopes that were coordinated to construct a virtual telescope the size of the Earth, made this incredible accomplishment possible. The Messier 87 galaxy's central black hole, which is around 55 million light-years from Earth, was seen in the EHT's image. A dazzling ring-like structure encircling a dark center area could be seen in the photograph. The gravity of the black hole causes light to be bent, producing the ring that denotes the boundary beyond which light cannot be refracted. Just the beginning came with this groundbreaking image. Since then, researchers have been deepening their understanding of black holes using this method. A group of scientists recently reported that they had succeeded in peering inside a black hole. Researchers used the EHT to monitor the gravitational lensing effects close to a black hole's event horizon. Gravitational lensing is a process in which the weight of a large item causes light from smaller objects behind it to be bent and deformed. The gravity of a large object, like a galaxy or a black hole, bends and distorts the light from things behind it. This distortion produces a magnifying effect that enables us to view items that would be difficult or impossible to see without it. The Albert Einstein's general relativity theory, which defines gravity as the curvature of spacetime brought on by the presence of large objects, was the first to predict that gravity would bend light. This hypothesis states that light passing close to a big object will travel via the warped spacetime along a curved route. The mass, length, and separation between the large object and the observer all affect how much bending occurs. The bending may produce a lens effect that enlarges and distorts the picture of the thing behind the large object if the alignment is just right. The lensing effect, for instance, can be used to investigate distant galaxies and their characteristics, like their mass and structure. It can be used to observe how dark matter bends light traveling through it, which is a kind of substance that doesn't emit light but has mass. Black holes can also be studied via gravitational lenses. We now have new insights into the physics of these mysterious phenomena because to the lensing phenomenon that occurs close to a black hole's event horizon, which allows scientists to investigate the effects of gravity on light. Scientists were able to discover more about what is happening inside the black hole by observing this distortion. Similar to the last photograph, the researchers were able to see a dazzling ring of light encircling the black hole. They could, however, this time notice fluctuations in the brightness of the band. These differences result from the intense gravity close to the event horizon of the black hole, which causes the light to warp and bend as it approaches our planet. The researchers were able to learn more about the physics of black holes by examining these variances. They discovered that the dazzling ring of light is actually made up of several smaller subrings that represent various light orbits around the black hole. This supports a finding from Einstein's general relativity theory, which explains how gravity warps spacetime. This finding represents a significant advance in our knowledge of black holes and their internal dynamics. It opens up fresh research directions and might aid in our understanding of some of the most puzzling occurrences in the cosmos. It would be an amazing achievement of scientific discovery if we could one day directly witness what is within a black hole with future technological development. In conclusion, black holes have long eluded scientists, but recent discoveries have made it possible for us to understand what is within these mysterious objects. Although there is still much to learn about black holes, These findings mark a significant advancement in our knowledge of the cosmos.